Arches and Lintels, Lesson 2, Modern Lintels. Precast reinforced concrete lintels. Precast reinforced concrete lintel beams are manufactured in fixed sizes and are ready for installation. They can be installed quickly, do not require formwork, and their material and dimensions match the building systems in which they are used. A disadvantage is that they can only be installed in exterior walls if additional thermal insulation is provided, ideally placed on the exterior side or aligned with the window side door frame. Another drawback, due to the fixed sizes, is their limited flexibility, because these components are typically pre-stressed. Cutting them to size is strictly prohibited. Block height lintels with immediate load-bearing capacity. Block height precast, reinforced concrete lintels match the height of the masonry blocks within the given system and the course height of walls built from these blocks. Earlier designs, still in use today, are simple trapezoid-shaped, reinforced concrete structures made with pre-stressed reinforcement. The number of such elements, placed side by side, must match the required thickness of the wall. These lintels do not need to be supported or undergo additional procedures. Once placed, they can be loaded immediately. Reinforced concrete lintels of block height with clay formwork are designed to be combined with clay hollow blocks. A C or U-shaped clay formwork surrounds the load-bearing pre-stressed reinforced concrete core. Only whole blocks should be placed in the bearing width of the lintel. They may only be laid in a conventional mortar bed. Their installation with adhesive foam or thin bed mortar is prohibited. Block height lintels with silicate formwork have also been developed for aerated concrete block systems. These lintels must be laid in masonry mortar with a minimum bearing of 20 centimeters. The U-shaped silicate formwork lintel is positioned with its legs facing downward during masonry work. Tension zone lintels. Tension zone precast, reinforced concrete lintels with a block height of 6 to 12 centimeters provide only the lower tensioned section of the final lintel. The compression zone above the lintel must be constructed on site, either by adding masonry or by pouring concrete. When using clay formwork lintels, the upper reinforced concrete sections are set into U-shaped clay formwork grooves. The typical heights of the elements are 6.5 or 8.5 centimeters. The lintels must have a minimum bearing of 12.5 centimeters and be put in a conventional mortar bed at the supports. Clay formwork lintels must be supported until the compression zone becomes load-bearing, with a maximum span of 1 meter between the supports. U-shaped monolithic reinforced concrete lintels. Both clay and aerated concrete block systems include a U-shaped lintel product that aligns with each system's dimensions. The U-shaped elements form a continuous permanent formwork for the cast-in situ reinforced concrete core. These elements must be assembled from separate pieces, so they can only be set up and poured with concrete when adequately supported. The clay U-shaped elements are typically 23.8 centimeters long and joined together with masonry mortar, providing a minimum bearing of 12 centimeters. A custom-sized formwork piece must be cut to fit the bearing area, thus avoiding cracks arising from a protruding position. Before concreting, insulation boards must be placed inside the U-sections adhered to the outer leg of the U-shape. Typically, the aerated concrete U-shaped formwork elements are 60 centimeters long and must be installed with a minimum 20 centimeter bearing. The elements must be joined together with adhesive mortar. Monolithic reinforced concrete lintels. The considerable advantage of monolithic reinforced concrete lintels is that they can be made in any size, with individually sized reinforcement and cross-section. Their disadvantage is that they require more on-site work, supported formwork, iron installation and on-site casting, and then removing the formwork. It may be an advantage if the proximity of the ring beam allows it to be shuttered and concreted together with the ring beam. The lintels should be designed with a reduced cross-section for external walls, leaving room for additional thermal insulation.